Hello everybody. Today we will be talking about static games with complete information. For these examples, we'll be talking about two-player games that are simultaneous move. The general format/timing of these games is that player 1 chooses an action from a list of X total actions. At the same time, player 2 chooses an action from a list of Y total actions. The important point about listing that these two occur at the exact same time is that action of player 1 has no effect on the action of player 2. This means that player 1 and player 2 receive their payoffs at the same time, after they both choose their actions. A classic example of this is a prisoner's dilemma. The premise of this game is that there are two parties that are separated and they are unable to communicate with each other. The aim of the prisoners is to minimize the total number of months that they spend in jail. They're given a deal. If no one confesses to the robbery, then they can only be charged for a minor crime, and the punishment is 3 months each. If one prisoner confesses, whether it be player 1 or player 2, the one that confesses gets 0 months. The one that does not confess gets 15 months. This is like a deal given to convince them to confess. The third scenario is that both of them confess. In this scenario, they each get 10 months of jail time. So what should they do? We can, instead of representing it in this long format with all of the numbers, we can represent it using strategic form in a matrix. Here you can see the different scenarios. Player 1 over here, player 2 over here. If player 2 decides to keep quiet and player 1 decides to keep quiet, they both only spend 3 months in jail. The reason it's -3 is to show that they lose 3 months of their life. Now, if player 2 decides to confess, but player 1 decides to keep quiet, player 1 then has to spend 15 months in jail, whereas player 2 gets off scot-free and spends 0 months in jail. The opposite happens if player 2 decides to keep quiet and player 1 decides to confess. Now, if they both decide to confess, they each spend 10 months in jail. Adding up these numbers, you can see in this scenario, they spend 6 months in jail in total. Over here, they spend 15 months. Over here, they also spend 15 months. And over here, they spend 20 months. So looking at this, one may think that the best option is for both of them to keep quiet, since -6 is larger than 15, which is larger than 20, and we may want to minimize the total number of months that they spend in jail together. This is wrong. That's because every single player in game theory works in their own best interests. It may seem a little bit confusing now, but I'll explain a little bit more about why this works and why the scenario in which they both don't confess anything is not possible. So, imagine we're player 1. We know that player 2 will keep quiet by some way. Maybe we made a promise to them outside, maybe something happens, but we know that they'll keep quiet. Now we look at the matrix this way. I got rid of the other side that was initially over here because I know that they'll keep quiet for sure. In this case, my choice is to, as player 1, is to keep quiet or to confess. If I keep quiet, then I spend 3 months in jail. If I confess, then I spend 0 months in jail. As player 1, since 0 is greater than -3, I would want to confess knowing that player 2 will stay quiet. Now let's switch it around. I'm still player 1, but I know player 2 will confess this time. Now my options are, again, to keep quiet or to confess. Looking at my options again, I'll see that if I keep quiet, I spend 15 months in jail. If I confess, I spend 10 months in jail. Seeing that -10 is larger than -15, I will choose to confess. Since I know that I'll confess in both cases, we can say that confess strictly dominates keeping quiet. Now, let's think that we're player 2, and now we know that player 1 will keep quiet. Now I change the matrix, deleting the part where player 1 confesses. Looking at this matrix again, I apply the same methods and I see 0 is greater than -3, so player 2 will confess in this case. And last time, now we are player 2 and we know that player 1 will confess. Same matrix, same method. -10 is larger than -15. Player 2 will confess. Again, we can see that player 2 will always confess, regardless of what player 1 chooses. So you may say, Jonaby, what if they pinky promise to each other, saying that, I promise that I'll say silent if you say silent? But remember, we're in a game theory class, and going back to the above example, if I was player 1 and I know that player 2 promised to me, swore on their life they would stay silent, then I would confess, because that meant that I would spend 0 months in jail. I know, this may seem immoral or wrong, but in game theory, everyone acts in their best interests. So thinking that they would both promise each other to stay silent, to stay in the best interest of the group, won't work, and is an unstable assumption. Now we have found the Nash equilibrium. This is the case in which they both confess and each get 10 months in jail. Thank you so much for listening to my video. This has been an overview of static games with complete information.